digital freight matching is like Uber, but for trucking. So when they have a load to move someplace, they're looking for a driver, there's a platform that they can go to be able to put their load in and get it so that they match to a closed truck.
A similar, maybe a parallel analogy, and that would be the internet, and the fact that, you know, in the 50s and 60s, we had computing technology. We had mainframe computers that were never designed to interoperate. The large computers were designed for a single purpose, banking, transportation, like airline reservation systems. At some point, if you wanted to, again, they were never designed to interoperate. There was no need for a banking mainframe to communicate with a transportation mainframe, reservation system mainframe like Delta. Actually, it didn't come from the university system. It came from the Department of Defense that was a little bit concerned that the telephone network had single points of failure. Being a circuit switch network, you had a single dedicated circuit between two connection points. And should that circuit be disconnected in any way, telephone pole goes down, cable gets cut, that network is dissolved. That connection is interrupted. So we need a network that can survive any failure of a single point of connection. So they wanted a packet switch network. So they wanted to actually interconnect, to develop a network that would survive an interruption, which is what came out of that was the packet switch network. So they connected 4 university systems, and the fact that the university systems, being academic computers, were used for academics, research. Universities had pretty robust mainframe systems. So the idea was, can we connect those mainframe systems with one another for the purpose of sharing information? The problem was each of those computers was designed individually with their own operating system, with their own networking protocols to connect it with individual terminals that were connecting to the mainframes. So what they had to do was define a canonical form, a common format for data to be transmitted. Well, rather than redesign the mainframe, they created a completely separate computer whose sole purpose was to transfer or to translate the information from that mainframe computer into a common format, one that could transmit from one computer to another. So these smaller computers that sat in front of the mainframe computers were known as IMPs, interface message processors. And so these would define that common format for the transmission of data. So now, if I had 2 different systems, I would have to create one common format. If I had 3 different systems, system A, system B, system C, I would have to create a transmission protocol between A and B, between B and C, and between C and A. So I have to have 3 separate translation protocols. Well, it doesn't progress in a linear fashion from there. If I add a fourth, A, B, C, D, now I have to have A to B, B to C, C to D, D to A,
C to
A to C, or B to C, B to D. Yeah, so I need 6. Well, if you add a 5th, now you need 10. There's a formula for it. N times N minus 1 over 2. N being the number of systems, N minus 1 being the fact that I don't have to communicate with myself. So, and that because A to B doesn't need a separate translation from B to A. So A to B works to translate. So everything's divided by 2. So anyway, so for 4 systems, you have 4 times 3, or 12, divided by 2, or 6. Now you got 5 systems, 5 times 4, 20 divided by 2, 10. You add a 6, you have 15. So if you've got, imagine 100 different computers, 100 times 99, now you have 4,500 separate translation programs. It's untenable. I mean, it's just unworkable. So the idea of creating an IMP meant that you only had to translate into that common format. So now it's a one-to-one. If you have 100 systems, you only need 100 translation programs just to get that system to connect to the canonical or common format. Therein lied the challenge. So this company developed IMPs to sit in front of the mainframe computers, and that was the start, the birth of an inter-networking protocol, internet protocol, or what we now know as the internet. And that's all evolved to be the TCP/IP, Internet Protocol Transmission Control Protocols that we all know and love, or we love but we don't know. Recently retired after 30 years with Bell South AT&T. The last 20 years of that was part of AT&T University, where I worked specifically with salespeople and sales leadership in the area of either sales and leadership skills, or because I have such a passion for the technology behind the products that we sell, they wanted me to teach the technologies, because I just think what we do is some of the coolest stuff in the world.